Hello everyone. In this video, we shall discuss how to solve systems of two linear equations in two variables. Now, systems of this type has the following form. Our first equation would be a times x plus b times y equals c, and our second equation would be b times x plus c times y equals f, where a, b, c, d, e, and f are real numbers, and x and y are our variables. Now, the solution set for a system of equation in two variables is a set of ordered pairs x comma y, which satisfy both of these equations. So when we solve for a system, we substitute the obtained values of x and y into both equations, and both of equations must be satisfied. Now, a system having at least one solution is called a consistent system. Now, if a system has exactly one solution, then we call it an independent system. And graphically, it's a set of intersecting lines where the point of intersection is the solution of the system. Now, if the system has infinitely many solutions, then we call it a dependent system. And graphically, it's a set of overlapping lines. And all the points on these overlapping lines are solutions of the given system. Now, if a system has no solution, then we call it an inconsistent system. So if it doesn't have a solution, then it means graphically it's a set of parallel lines. So which means there's no point of intersection. Now, algebraically, we can solve for systems of equations by using either the substitution method or the elimination method. But in this video, we shall focus first on using the substitution method. So let's consider this first example. So our first equation is 2 times x plus 3 times y equals 1. And our second equation is 5 times x minus 2 times y equals 12. Now, when using substitution method, we can choose either equation 1 or equation 2. And then we either solve for or we solve for either x or y. So in this case, now let us try to use equation number 1, and then let us solve for x. So in equation number 1, we have 2 times x plus 3 times y equals 1. So if we solve for x, we're going to transpose 3 times y to the other side. So we get 2x is equal to negative 3 times y plus 1. And then we divide both sides by 2. Then this will give us x is equal to negative 3y plus 1 over 2. Now, this equation must be substituted into the other equation. So our other equation here would be equation number 2. So using equation number 2, we substitute this negative 3y plus 1 over 2 to every occurrence of x. Now, equation number 2 is 5x minus 2y equals 12. So we can actually replace x here by negative 3y plus 1 over 2. And then we have minus 2y equals 12. Now, multiplying both sides by this equation by 2, which is our least common denominator, then our equation will now become 5 times negative 3y plus 1 minus 4y is equal to 2 times 12, which is 24. So now we have an equation having a single variable y. So using linear equations in one variable, we can solve for the value of y. Distributing 5, it will give us negative 15y plus 5 minus 4y equals 24. And then negative 15y minus 4y is negative 19y. And then positive 5 will be transposed to the right side. That will become 24 minus 5, which is 19. And then dividing both sides by negative 19 will give us y is equal to negative 1. Now, we're not yet done here because we still need to solve for the value of x by substituting negative 1 to y from each of the two equations. So in here, now we can actually use equation number 1 and substitute the value of y. So we get 2x plus 3 times negative 1 is equal to positive 1. And then this gives us 2x minus 3 equals 1. Transposing negative 3 to the right side, we get 2 times x is equal to positive 4. And then dividing both sides by 2, we get x is equal to positive 2. So therefore, our solution set for this problem would be the ordered pair x equals 2, comma, y equals negative 1. So as we see here, that the system has exactly one solution. So we call this a consistent and independent system. For our next example, let's consider the following system. Our first equation is x minus 5y equals 8. And then second equation, we have 2x plus y is equal to 10. So we can choose from either equations 1 and 2, and then we solve for either x or y. So in this case, we can use the equation 2. Let's try to use equation 2, and then let's solve for y, because solving for y, we will get a simpler equation. So we get 2x plus y equals 10, and then transposing 2x on the other side, we get y is equal to negative 2x plus 10. And then we use this equation and substitute it to equation number 1. So we get x minus 5y equals 8. And then the variable y here will be replaced by negative 2x plus 10. And then simplifying further, now we get x plus 10x, and then we have minus 50 equals 8. And so we get x plus 10x is 11x, and then negative 50 when transposed to the right side, now we get 58. And then dividing both sides by 11, we get x is equal to 58 over 11. Now substituting 58 over 11 to any of the two equations, we will get the following. So let's try to use equation 2. So we have 2x plus y equals 10. And then since we know that x is equal to 58 over 11, we replace x by 58 over 11, and then we have plus y equals 10. And then multiplying both sides by 11, we will get 2 times 58, which is 116, plus 11y is equal to 10 times 11 is 110. Transposing 116 to the right side, we get 11y equals 110 minus 116, which is negative 6. And then dividing both sides by 11 will give us y is equal to negative 6 over 11. So therefore, our solution set would be the ordered pair x equals 58 over 11, comma, y is equal to negative 6 over 11. So since our system has a single solution, then we call this system a consistent and independent system. Okay, next, let's try to solve the following. So our first equation is 2x plus y equals 7, and our second equation is 4x plus 2y equals 9. So here we can use equation number 1 and solve for the variable y. Okay, so writing the first equation, we get 2x plus y equals 7. Transposing 2x to the right side, we get y is equal to negative 2x plus 7. And then substituting this thing into equation number 2, which is 4 times x plus 2y is equal to 9. Now we get 4x plus 2 times negative 2x plus 7 equals 9. And then simplifying further, we get 4x minus 4x plus 14 equals 9. So 4x and negative 4x will cancel out. So we're left with 14 equals 9. But this thing is false. 14 cannot be equal to 9. And as you can see, there's no variable left. No, the variable x is eliminated here, which means that this system has no solution. So if the system has no solution, then that means this system is an inconsistent system. And then finally, for our last example, we have x minus 3y equals 6 as our first equation and 3x minus 9y equals 18 as our second equation. So for the solution, now let's try to use equation number 1 and solve for x because this will give us a simpler equation. First equation is x minus 3y equals 6. So we can solve for x by transposing negative 3y to the other side. Thus, we get x is equal to positive 3y plus 6. And then using equation number 2, which is 3 times x minus 9y equals 18, we will substitute 3y plus 6 to x. Thus, we get 3 times 3y plus 6 minus 9y is equal to 18. And this will give us 3 times 3y, which is 9y. And then 3 times 6 is 18. So 9y plus 18 minus 9y equals 18. Now, observe here that 9y and negative 9y will cancel out at the left side, and we're left with positive 18 equals positive 18. And this is always a true statement because 18 is always equal to itself. So what does this mean? Well, this means that the system is dependent, which means that the solution of the system would be all the ordered pairs or all the points lying on the graph of each of these two equations. Okay, so thank you for listening for this video. I hope you learned about solving systems of two linear equations in two variables using the substitution method. So don't forget to subscribe to my channel. Thank you.